planetary epicyclic gear trains. So there's a different type of gear trains which involves an arm. So you'll see that if you imagine uh, this is actually fixed. You can see the bearing here. So this gear is known as sun gear because the other gears, 4 and 5, will rotate around the sun gear. So it's like a sun-planet system. Okay, and that's possible because of the planet or carrier or the arm. Okay, so the components of a planetary gear system is a sun gear, always there, an arm, and then you could have multiple gears. You could have 1, 2, 3, so on, planetary gears. The difference between this and what we have seen so far is that we need two inputs. We need to specify inputs of either the sun gear and the arm or the sun gear and the planetary gears and keep the arm free. So it's a two input system. So normally what is done is one of them is fixed. So the arm is fixed. If the arm is fixed, then its speed is going to be 0, and you can use that to essentially solve for other variables. Okay, so for this particular setup, n5 minus n3 divided by n2 minus n3 is equal to E. E is the same formula written earlier, driven divided by driving. So this is a formula you want to. So n5, what's n5? N5 is the last gear, and A is the first gear. So you can actually generalize this formula as n last minus NA, which is n arm, divided by NF, which is n first, minus NA equals E. Okay, so let's use this and solve one problem. So here is the problem. Okay, the sun gear is the input and is driven clockwise at 100 revolutions per minute. The ring gear is held stationary. So this is the ring gear. That is actually held stationary and fastened to the frame. Find the revolutions per minute or the speed and direction of rotation of the arm and gear 4. So we need to find what is the speed of the arm. The arm has the number 3 and N4, which is the gear, planet gear 4. Okay, and you can see these numbers. 80T means 80 teeth, 30T means 30 teeth, 20T means 20 teeth. Okay, so that's one. We also need to find the direction of rotation. So to find the direction of rotation, what you do is the following. So this is locked. Let's unlock. I'll write it down. Unlock ring gear. Okay. Lock arm 3. Okay, so this is a procedure you'll use to figure out direction of motion. So if you lock arm 3, so what's given? Is it given clockwise? Okay, we're given the rotation of the sun gear. Sun gear is driven clockwise. So sun gear is spinning this way. So the planet gear will rotate in this fashion, right? Because this point, common point, will have a speed downwards. Okay, so the ring gear, the question is how will the ring gear rotate? So again, use the same logic. There's a common point between the ring and the planet, and this point has to be moving this way, right? Its speed. So for it to move with the speed v upwards, the ring gear should also rotate this way. So the ring gear and the planet gear are rotating counterclockwise, and the sun gear is rotating clockwise. So planet and ring are rotating counterclockwise. Okay, so that's the direction. Now let's go to the values for the actual speed. So E is on driving to driven. Okay, so driving gears are two drives, two drives, two drives four, and four drives the big gear 5. So 2 and 4 are the driving gears, and the driven gears are, since 2 drives 4, I'll put it down, and 4 drives 5, I'll put this down. So turns out that 4 cancels off because it's the idler. So N2 is 20 and N5 is 80 minus 0.25. Okay, so now use the formula NL minus NA divided by NF minus NA equals E. So last gear, okay, so ring gear is fixed, right? That's what's going, it's fixed, so it's going to have 0 speed. NA is unknown. We don't know the speed of the arm. And first, the first gear, we know it's moving clockwise at 100 revolutions per minute. We're just going to use negative sign for clockwise. Minus NA equals minus 0.125, sorry, 0.5. Okay, so with this, we can solve for NA. It's one unknown, one equation. NA is minus 20 revolutions per minute. In other words, NA is 20 rev per minute clockwise. Okay, so that's for one part. We just have to solve. So we got the arm. We got this. We need to find the speed of gear 4. Okay, so for gear 4, we write a similar expression as we written for the arm, like a similar one, like this one. So N43 divided by N23. The N43 means it's N4 minus N3 divided by N2 minus N3 equals 3 driving 3 driven. So N2 has 20, N4 has 30. Okay, so we can write N4, which is the unknown, minus N3. N3 is speed of the arm, so it's 20. N2 is 100. N3 is minus 20 equals. Okay, so one equation, one unknown. You can solve to get N4 is 33.5 rev per minute or 33.5 rev per minute. Either put a positive sign or say rev per minute CCW.